Hi, this is Nalini Elkins with Industry Network Technology Council. Welcome to our IPv6 address planning lab. This is the fourth, well, gosh, maybe the fifth session of this entire series. This is a collaborative project between the India Internet Engineering Society and Industry Network Technology Council, both of whom are nonprofits. And we are funded for this series of webinars from a grant from IIESoc Asia, which is a part of the AP Foundation. Thank you so much to AP. We have been funded in the past by Aaron, and we are doing a collaborative project with them as we speak. This is a of course, AP, Nick, and Aaron are two of our internet registries. The vision is to have IPv6 deployment at enterprises. This is really one of the final steps towards full deployment of IPv6 throughout all our networks, both internet and private. And so this is a very big push for everybody to go ahead and finish it. So the aim of this project is to first provide training and then do an analysis of security and applications do an analysis of security and applications. You know, I'm pausing just for a second because I'm getting a note from somebody saying that the screen is blank. Can somebody please send me a quick note to let me know that you are hearing me and seeing me okay? Because if most people are, then it's likely a problem with that one person, unfortunately. Perfect. Thank you guys so much. Okay, yeah. Okay, yeah, gosh. I don't know what to say. Some people are not being able to see the screens, but most people are. So please, I'm so sorry. I guess we'll be sending out both the foils as well as the recording. So, okay. So anyway, so we're doing a deep dive into security and application conversion, and so that will be something that we will talk more about. And then we are starting to help enterprises actually plan their IPv6 deployment. Do plan to hear more from us on that whole area, in particular in the Asia Pacific region. This is a teaser. As I say, as everybody gets their ducks in a row, we will have some announcements in that area. So we've done a number of classes so far, and now this is this will be a follow-on webinar to the IPv6 address planning. Last week I spoke about the planning from a theoretical point of view, and Mike will now speak from a hands-on practitioner point of view, from the point of view of a very large enterprise. So Mike is the lead network engineer at Blue Cross Blue Shield of Michigan. For those of you outside the country, it is one of our largest health insurance companies. In the United States, we have private healthcare. He has a vast background in many areas. He's built networks, he deploys networks, and most of all, he troubleshoots networks. And Mike and I met, probably, gosh, 15 years ago when we were on the design team to bring IPv6 to the Blue Cross companies. He and I have written a number of internet drafts and RFCs together and are continuing to do more. So Mike, I'm going to turn it over to you now, and please take over. Thank you so much.
Thank you, Nalini, and welcome everyone. What we're going to try to do today, and I'm going to apologize in advance, we got a whole lot to cover, and I'm going to be moving through it real quickly, and I'm even willing to stay later. If you all want to be tortured some more, I'm willing to stay and inflict more pain. But some of this is pretty detailed. Some of it's pretty intense. So I'm going to go quickly over the things I don't think I need to dwell on and spend more time on the painful stuff, on the bits and bytes. And Nalini will watch me and manage time. And also, Nalini, I think, can they put questions into the chat for clarification, and then we can slow down and stop and address questions if we need to. Is that going to be possible?
Yes, absolutely, absolutely.
Fantastic.
Please go ahead and put things into the chat in the questions window. And I'm so sorry, I forgot to say, do plan on about an hour and a half for this, and we may run even over that. It's just, there's just a lot to say, and yes, thank you, Mike.
Okay, yeah, I'll do my best. I know nobody wants to hear that, but we'll keep it as concise as possible. So anyway, let's get started. Here's what we're going to do today. Our agenda is to take all this fantastic information that Nalini presented last week, and I really did think it was fantastic. But the issue for us large organizations is we get all fired up and we see this great information. So now how do we apply it in our large organization with all the things that we've got going on? So that's the main thing that we're going to cover, and then we're going to see how that can affect or even direct IPv6 address planning, and then we're going to see how we can map all of this into an IPv6 address and get some benefit out of it, and see what kind of impacts it's going to have on our existing operations. And all along, I'm going to try to do examples as much as I can, because that's what I find most illuminating. So Nalini, next slide, please. So this is Nalini's rules from last week. I borrowed one slide from her presentation, but hopefully you all remember that. If you did not see this, go out and look at the recording. It is absolutely fantastic. There is so much incredibly good information in there. And so I'm going to build on this. You'll see a lot of references to these rules. And so when you see a slide that says, oh, this rule 4 is being represented here, this is what it's talking about. So feel free to go back and look at this or look at that presentation. It was great. So Nalini, next slide, please. So let's go ahead and get started with sort of profiling our large organizations that we all work for. We have large numbers of everything. We're very focused on dollars. We usually span large geographic areas. Go ahead, Nalini. I'm going to try to zip through this stuff pretty quick, because I think we all know who we are and what we're like and how messed up we are. So what we do is we take these large structures that we are and we try to break them down logically, and we might break them down into continents or countries or buildings or this or that, or sometimes it's divisions or subsidiaries. And these are all dictated by business factors, and it depends on the industries that we're in, the markets that we're serving, demographics, etc. All this business stuff that us techies don't really understand anyway. And this varies by the industry that we're in and how big we are and objectives or what's hot on a given day. And next slide, please. So what we want to do is take all this great information that Nalini gave us last week and then merge that with this business information that we have and create an address structure that will work for us and provide value. What we're doing here is going to mainly pertain to internal addresses. In other words, we're going to come up with this grandiose addressing structure. When it floats out on the internet and somebody that's never heard of you sees it, it's not going to mean that much to them. But it will mean a lot to us internally, but also maybe to other entities that we work with or communicate with, or maybe we're even part of. So we may have subsidiaries, close business partners, divisions of the company. This may even apply to customers in some situation. And the big bullet there is that it will depend on the relationship. So we need to understand those. Next slide, please. And this will also apply and does apply in the IPv4 world. And what we do there usually, and I think this will apply to most of us, is we're using private addresses on the inside and public addresses on the outside. So we need to accommodate that structure as well. So how can we do this and all the other stuff that I've just talked about in IPv6. Next slide. And add to that, we're all very intensely focused on network management. So not only are we big, not only have all these devices, but we need to manage them. We need to take care of them. We need to know what they're doing. And so we usually have critical functions like stocks and NOCs and help desks. And we need to provide them with as much information regarding the network and the devices on it as possible. So if we can build that into these addresses, then it's immediately recognizable for those types of situations, for those people, and for tools that are going to be using it. We do that to some degree today with IPv4, but we can do even more, I think, with IPv6, and that's what we're going to find out today, if that's going to be possible. Next slide. So I know I just gave you a huge morass of information that we're going to try to bring together and try to create an address plan with all that. So how can we do that? Next slide. It's as confusing as that previous slide looks, but we're going to try to take all these characteristics, all that information, all of our requirements, all the relative data, and somehow move that into an IPv6 address. So the question is, how can we possibly get there from there? So we have to do some things first. We have to meet with some people and gather some information. Two basic areas. First, yes, we need to talk to the business. We're usually not very good at that, but that becomes necessary here if we want to do this right. We need to talk to the business strategic planners and to management, understand where they're going, what their priorities are, what their plans are, what scope changes are there. Questions like, will the business be expanding in other regions? What about the markets that we're going to emphasize? What demographics are we dealing with? Are numbers increasing or decreasing? What about money? Does that matter in this equation? Is our customer base growing? Are we getting more or less employees? And then most of all, business partners, or what I'm going to be referring to as entities. They're becoming increasingly important in our world, and we're getting tighter and tighter with other organizations. So that was the business side, but we also need to talk to our own people. So there's technical architects and IT strategic planners, and the questions will be different, but this information is equally critical. So the types of information there, the numbers of clients and servers and networks, how much data, how many locations do we have to deal with? Performances is always going to be critical. We've already talked about management. That's extremely important. One of the tougher questions is to determine what's coming at you. So are we going to have new apps? Are we going to have new sites, new customers, new vendors to deal with? And then, of course, we need to deal with cloud and or hybrid, because I think that's creeping into all of our environments. And one key point is that, as we talk to these people, whether it's in IT or not, and Nalini, I'm still kind of on the last slide, but thanks for trying to move me along. I'm trying to go fast too. We want to get everybody's input, get all these areas that you think may be affected involved. And one of the reasons for that is you do need their input, but also if you just dump this on them later at a later point in time, they're going to be fighting you instead of supporting you. So get people on your side. And next slide, please. So here's what with that as a background, here's what we're here to do today is to create an IPv6 address planning document. And this is my framework for doing that. Doesn't mean you have to do it this way, but here are 7 sections that I think you do need to address. Use this as a framework, adapt it to your situation. There may be sections that you want to add to this, maybe even things you don't think are important in your environment. So view this with an open mind, know that we're all different, know that we're going to make some changes to fit our environment. But I think this is a good framework, and it's worked for a few that I've worked with and talked with. And in red letters there, do this first. I'm going to emphasize that a couple of times, and here's why. What we probably want to do is go ahead, let's get our address, let's start deploying IPv6, let's just get it out there. And I think that's a mistake. I think you want to do this first, because then when you do start to deploy, things will go a lot better. I'm not going to go into detail on that now, but you'll see a few reasons why I say that. And again, I will say this probably multiple times because I just think this is a good idea. And next slide, Nalini. So the very first of the 7 bullets there is to figure out how much address space do I need? And that's usually defined by a /XX. And Nalini covered that in great detail. We're going to use some examples there. So how do I figure out how much I'm going to need? And that means, what am I going to do with this? How am I going to use it? And one of the key areas that I've found is determining what entities that you're going to deal with. And again, an entity could be a division of your company, a business partner, it could be a subsidiary, it could be a building, it could be a city. So it depends on what makes sense for your organization. So you're going to want to figure out how big does each one of these subnetworks need to be, and then try to determine how many you need, and that will help you determine what your /XX is. And again, that's the address space that you're going to request. We'll talk a little bit more about that. Now, this is going to get a little confusing because I'm talking about the YY of the XX. All that means is that when you do get this big old address space of IPv6, you're probably going to break that down into sub address spaces, and that's what the YY is. I'm going to try to shed some light on this because I'm still dealing with this myself, and I still find it confusing. So I'm sure you all do, but we're gonna make it crystal clear within the next hour or hour and a half, as he said. So when you do break it down into your YYs or your sub networks, each of those, and let's say that's a division or a subsidiary, they're going to have their own, regions, cities, buildings, floors, departments, etc., more than likely as well. So we need to break it down for them. So here's our first reference back to a rule, and that was rule number 1. We want to allocate a whole bunch of /48s for that subnetwork. So let's assume that that's the case, and that's what we learned last week. And I'm throwing out an example. I don't know if this was in Nalini's presentation last week, if we said how many 48s does it need, because it's hard to determine because it's so dependent. But I'm going to throw out a number of 4K, and we'll see in a little bit why I think that's a good example. But again, your mileage may vary. And one thing we're going to do here is you're going to have a bunch of these. You're going to have a bunch of divisions or partners or buildings or whatever you want to break it down into, and it's probably all of the above. But whatever the biggest one of those is, that's what you're going to want to set for everything. So, let's say that I have New York as my biggest subnetwork and Atlanta isn't as big as New York, but I'm still going to give the same size of address space to New York, Atlanta, and even smaller cities, because we need to keep that consistent. And I hopefully I'll say that again on a subsequent slide. And I think next slide, Nalini. So I'm going to try to shed a little bit of light on that because I think it's confusing. So let's do an example of the thought process that you might go through applying this to your organization. So let's say your enterprise has 100 such entities, again, business partners, et cetera, and they may break down in various ways. It may be by continent, it may be by country, it may be by city, it may be by industry or function. But however you break it, may be combinations, and it may be all of the above. So, but let's say we have 100 of those today. So I'm keeping that number in green there. And let's say our biggest subsidiary or entity is US sales. And it has requirements, as we said, for 4K or less /48s. Again, back to rule 1. And how would we come up with that? Yeah, we don't know. So one example would be like, let's say US sales has 20 locations in every state in the US. And so that adds up to a number that's less than 4K. We want to build growth in there. So as with any planning, there's some fudge factor, and you need to think ahead and try to project, et cetera. And so that's what we're doing here. Again, I'm going to reiterate that whatever we come up with for the biggest one, which again, we're saying is US sales in this case, and New York in my previous example, we're going to give that amount, even though it may be more than they need, or the same YY, to all of the rest for consistency. Okay, so now pausing for just a second, what we said is we talked to the business and we found out what they're going to do, and they forecasted a growth of 100%. In other words, we're planning to double in the next 3 to 5 years. So now all of a sudden we take that 100 number. We have 100 of these entities today. We're going to grow 100%. So now we got to use the number of 200. Okay, that's kind of making a little bit of sense, I think. So now let's go back to Nalini's rules, and we want to add room for expansion to that. And so that's rule number 6. And rule number 4 says when we're building this address space, which is what we're doing here, we're trying to build how we're going to use all these 128 bits that Nalini described in detail last week. And she talked about a thing called a nibble boundary. And we want to build on a nibble boundary. So the closest nibble boundary above 200 is 8 bits or 256. So hey, that sounds like a good number we should maybe plan for. And it actually kind of makes sense and is based in math, and there's some thought there, and it's starting to sound pretty cool. And I'm going to say this, aim high, in other words, 256 is sounding good, but if anything, go higher than that. And the reason is you want a bigger address. You want to get the biggest address space that makes sense to you. That way you never have to go back and revisit this. And I'd say jokingly, also do it out of respect for all the internet routing tables, because if you end up having to go back or have multiple address spaces, each one will represent another entry in a routing table, and we don't want to fill up the routing tables in the internet or in our network or anywhere else, because then our routers don't perform well and our network stinks. So again, be conservatively high is the final bullet there. I think next slide, Nalini. So it's sort of to summarize that, what we've gone through here is that we need 256 subnetworks as we think forward and doing our planning. This requires 8 bits, so that leaves 28 bits, and we're going to look at a map of the address space, the IPv6 address, and see how this breaks down in a second. So that leaves 28 bits for a prefix. So to accommodate our projected business and network requirements, we think we need a /28, and we would subdivide that into 256 /36s. So that's what we have accomplished, or that's what we sought to accomplish. And I'm going to pause for questions in just a second to see if there are any. But I just want to say that's the kind of thought and math that you want to do to see if you can come up with a number like this. This isn't easy. It'll take you a few iterations to understand it and then provide some meaning to it. But if you're willing to go through this hardship and pain, and the final comment at the bottom there is, if you go through this type of information and effort information and get these types of results, the RIR that you're going to request this address space from will be much more likely to grant you your request, and you will be much better positioned to use it if and when you do get it. So this is some of the reasons why I say, again, do this first. So I think this is a decent point to pause it and see if we have any good questions we want to deal with. Nalini, can you comment on that?
Yeah. Actually, there's, I think everybody's just following along, and there is one great comment, which is that this is really kind of a tabletop exercise that you're talking about. It's a tabletop exercise where you lay out your network, and then it gets you into a position to come up with a justification to your registry. One of the things we should probably do at the end is talk about justifications, because some address spaces, like some prefixes, like a /48, you may need very little justification, but for a higher one, you'll need more. And so let's, as I say, but let's talk about that at the end, because this is just great.
Yeah, and whoever brought that point up and your point, those are both really good points. And let me just say that, yeah, almost for sure, if all you wanted was a /48, yeah, you'll get that almost for sure. And the lower the number, the more addresses you have. So going all the way down from a /48, to a 40, to a 32, to a 28. 28 is a pretty big number. So I'm doing this under the assumption that we're planning for a large organization with a lot of business partners and a rosy future, and et cetera. So And somebody asked me the other day, like, okay, so you built a case for a /28 here. What's kind of the default answer? And I would say that's probably for a large organization, a /32. But again, what we want to do is put a little bit of thought into this and do what makes sense for our organization. And so, yeah, and tabletop, yeah, you could tabletop also because you want to leave it on the table because you might revisit this several times before you come up with your ultimate answer. Is there any other questions we should talk about at this time, or should we move on?
Yeah, no, I think we're fine. Let's go on. There are a few more questions, but let's get them at the end.
Okay, yeah, I'll leave you to decide what questions we should deal with immediately and what we can put off, and I'll just keep trying to move as fast as I can. Okay, so I'll say next slide then. Okay, so now we're on to another section of our planning document, of the 7 sections. And this one's extremely painful because we're going to break down the bits of the 128 bits in the IPv6 address. Now, hopefully this will actually shed some light on some of the things that we've talked about already. So if we look in the blue letters here, that's how we're proposing to break down our address space. So if we get this /28, here's how we would use it, and here's how those bits would derive meaning and hopefully value for us. So I'm just going to walk through them real quick, and then we're going to be looking at this in other ways throughout the rest of the presentation. But this is a good base slide as you, and I think most of us will need to review this a couple of times. You'll come back to this slide because it's hard to wrap your head around this address with all these 128 bits in it. And I mean, V4 is hard enough, right? And there's a typo on this slide, but this is how we're going to break down the /28 into 256 36s, and it says 40s there, and that's just wrong. So if we just look at the bits real briefly, the ends, those are the /28s bits. That's our network prefix that we're going to get hopefully from an RIR. So that's the first 28 bits. Now the next 8 bits, AAAAA, are the 256 36s that we're going to subdivide this into for each of our sort of sub-organizations or business partners, etc. And then the X's are the bits that are allocated for the 48s that we've been talking about and that Nalini talked about at great length in the presentation last week. Now, we haven't talked about the rest of these bits yet, but I'm threatening you, we will. But the next few bits are the S's, and those are subnets. And the subnet is very similar to what we deal with in IPv4, and we will be talking about that. And then all the rest of the bits, the last 64, are host bits. And we will talk about that in some detail too. So I think that's painfully enough for that slide. So let's go on to the next slide. So that should accommodate our business requirements and technical requirements that we went through excruciating pain to determine in the slides previous to this. So, but let's just talk about the X, S, and H bits. We can use those however we want as an enterprise, and we have a recommendation here as to how we can use it and provide the most value. But here's an example of what that would look like. Now, we've talked about that we think we're going to get a /28. We're going to break that into /36s. Now, and then each of 36 will have 4K 48s. The rest of this we haven't really talked about, but each /48 will have 64,000 subnets, and each of those subnets will have 18 quintillion, and yeah, I didn't know what that was either, hosts in each subnet. That just seems like an insurmountable number of addresses. That's something we have to get used to. There will be more than you think you ever need, but as you get deeper into this, you'll see ways that you're going to use these up. And we kind of have to shift our IPv4 thinking to IPv6 thinking and just live with these big numbers and even learn how to say them. And you'll see a couple other examples there. And if you're into math, it just blows you away. But here's an example. So we can see the whole thing there, starting with the 2600 150, and that is a full IPv6 address. I think, as Nalini has pointed out in subsequent sessions, that we can abbreviate that and abbreviate all the zeros so it can make it look a little more humanly readable. But let's just break that down to talk about what some of these sections mean. So the /28, and I'm just looking at the bottom line now, the /28 that we were assigned is 2600:150. That's our /28. We're going to break that into /36s, and in this case, let me back up a second. So the prefix, the /28, is going to be the same for all of our addresses, but now we're going to break it into different /36s. And what we're saying is this /36, if you can see the bold font, is 0:1. And yeah, it breaks the colon boundary there, but that's okay. That has to do with the fact that we have a /28 as opposed to a /24 or a /32. It just, and that's okay. So what we're saying is that's /36 number 1, and that doesn't mean anything to us yet, but we're going to try to provide some meaning to that. And then we're going to look at the /48 within that /36 is next, and we're going to call that /48:001. I'm not getting very creative. And then subnets we have not covered, but we're going to say it's subnet number 2, and then in that subnet it's host number 1 or 0001. So that's how that address breaks down. We've now defined a couple of the first sections of the address that we are going to put together here and provide meaning to and structure within our organization. And we're going to now go on and try to define the rest. I was going to say we may want to pause for questions again with that example, but let me just go through that. Did any come in that? Does that make sense? I want the example to make some sense at this point, especially the first half of it, where we've already covered those, because we're now, this is the whole point of our lab sessions, is to take that great theoretical and technical information that Nalini presents, and now how do we apply that in our environments? And that's what I'm attempting to do here. So just to summarize that, though, while you think if you have any immediate questions. So we assumed, again, that with the /28, we'll have 256, up to 256 internal, external entities for which IP connectivity is required. Each of these entities gets a /36, and that's pretty huge in itself. And our goal is that that's going to accommodate everything that we got currently and any projected growth. So then each of these /36 entities, and again, we don't know yet, is that a city, is it a country, is it a division, etc. We'll break it down into /48s because that was the recommendation, I believe, of Rule 1. So that's kind of where we're at. And Nalini, is there any immediate questions, or should we march on?
Okay. Yeah, well, okay. So yeah, there's questions, and most of them we can hold to the end. Okay, so now I'm getting some stuff where people are like, my eyes are crossing. You know, that's a lot.
Me too.
and yeah, no question. I mean, as I say, Mike and I have been beating our heads on this, you know, for years now, and have done this, you know, a fair amount. And so what I'm tempted to say, instead of having you go over this again, is hold on. You know, you'll have the recording, you'll have this again, so you can listen to it. And what I'm thinking too is send me some notes, because what I'm tempted to say is Mike and I can have an open discussion period where, you know, like you guys tell us, because that sounds like breaking out subnets is kind of an issue. And so we can just say, we'll talk about these 5 issues, and people just come and say, okay, can you go over that again? Because it's as I say, there's a lot more to cover. I'm just saying. Does that make sense to Mike? Does that make sense to you?
No, it absolutely does. And let me just reiterate kind of what you said. perfect questions, perfect comments about eyes crossing. Everybody's eyes are crossing on these subjects, especially the first few times you're exposed to it. And even afterwards, I can say my eyes are still crossing. So don't worry about that. We'll revisit this numerous times. Don't expect to catch this on the first pass through. If it makes any sense at all and you're ready to get started, yes, we all need help with these areas, and there are experts out there that can help us. So just know that, this is the initial exposure. We'll follow through. I'll certainly help however I can. And Nalini is one of the greatest helpers of all time for things like this. So just know that, help is out there and that you will catch on to this eventually, but it will take time. This is, like I said, painful, intense stuff. And that's why there's so much of it and why it's taken us so long today, because we're trying to do it justice in a small amount of time. So I'm with you. Whoever said that, I'm with you. I feel your pain.
No, I totally, and as I say, we want to keep going, but I think I really feel like, and guys, take a look at my presentation too, because I have a slightly different view of how to break out subnets. Different things kind of make sense to different people. Everybody, comes onto this a little differently. But what I really feel like is we should probably schedule next Thursday at this time for a group discussion. And you guys come if you want to, but let's keep going then, Mike. Thank you.
Haven't we tortured them enough for 1 month? Yeah, go ahead with okay, so that's what we came up with, the 256 and the /36s, and that looks like it would pretty well map to our organization's business and networking needs. But what if the organization is completely different? And somebody out there's got to be asking that question. Well, the IPv6 address space is very powerful and flexible, and so we can do different things with it. We can kind of do whatever we want with it. Nalini had some examples last week that were completely different than what I just went over. But let me give you a couple more on the next slide. A couple more example ways of using that. Let's say that instead of having 256 business partners, we don't have any business partners. We just have buildings in every city of the world, and we need a whole bunch of /48s for each building. So what we could do is we could take our /28 and divide that into 1,000,000 48s. So that's probably way more than anybody has buildings or anything else. And each of those /48s would have 64,000 subnets, and each of those subnets would have 18 quintillion addresses. So that sounds like more than enough for that type of a organizational need. So that as a final alternative, let's say that I don't even care about buildings. All I have is just gazillions and gazillions of hosts out there, IoT devices that we don't even know about today. So what I'm going to do is take my /28 and break it into all host bits. Then now I can have 1,000,000 hosts, and who ever heard of that word before today? I hadn't, but it's a 1 followed by 30 zeros. We can have that many hosts. That should accommodate us. And I'll say one more thing. In other words, this flexibility is, we probably won't need things like this. We probably won't need that many, but the point is that the IPv6 address space is big enough and flexible enough, we can do almost anything with it. And one more, hopefully not confusing point is that at this point, if we're looking at a completely different type of organization and needs, maybe /28 isn't the right answer. We don't need something that big, or I guess possibly we could even find that we need something bigger. But so that's, and I think that's what the person that said the tabletop, that's, part of the tabletop as we start to figure this out and make changes to it. So just know that, for now, that the address space is very big, very powerful, and very flexible. And I think mercifully on to the next slide. So let's talk just a little bit about the address types and our global network prefix and how that fits into there. So a couple recommendations here are, when you go to get your address space, do you want it to be provider independent or provider dependent? And then what the heck does that mean? And I think Nalini covered that last week, but basically it means you're going to get it from the RIR, like Aaron or Apnick, or you're going to get it from your ISP. Now, how would you make that decision? And most of us are recommending go provider independent. reason is it's better for doing multi-homing, or if you switch ISPs or add ISPs, you know, there's a bunch of different reasons, and it's kind of yours, and you can control it more. Now, there is a slight fee from your RIR for getting a PI address space. So if that, it's a nominal fee depending on the size of the address. But, you know, just somebody, again, we're focused on the bottom line in our big enterprises, and I know how cheap we are, so it can be a factor. I'm suggesting that it not be a factor, that you go in that direction and get your own GUA. So what is a GUA? A global unique address, and it's one of the types of addresses that are there in IPv6. And again, I'm pretty sure Nalini covered that, so I'm not going to go into great detail there. But what we're saying is that that's the type of address that you should be able to use for most all of your IPv6 traffic. And in our case, it will start with the global network prefix that we got from the RIR or the ISP. In our case, it was a /28. And in our case, that is the global prefix, and that's what all of our addresses will start with. And we actually saw that in one example already. And I think that's all on this slide. So a couple more address types are link local. And again, previous presentations addressed this, so this is kind of just a quick refresher to know that they're there. Link local is always going to be there. You need that for some of the core functions of IPv6, and they always start with FE80. And then your GUA addresses can also have a little special spin on them called temporary or privacy addresses, which change all the time. And we will probably, Nalini, I think you addressed this in previous sessions, talk about, you know, it's beyond the scope of this presentation, but there are some security implications to that that may be important to you or may not. So I know for me, in some situations, that temporary privacy addresses could be a good thing, and in certain situations, I want nothing to do with them because they're changing and they would cause me all kinds of problems. So just know that they're there for now, and I think we can go on to the next page, which is we have one more address type, I think, and EULAs. And EULAs are sort of the equivalent of the private address. They're a little bit different, but they're a way in IPv6 to deal with that type of situation if you have that type of requirement. And from previous sessions, I know, because I even said this at previous sessions, we can, and in fact, we showed it in one of the previous labs, we can have multiple types on the same interface. And you can have multiple of a given type on a given interface. So know that. But, and here's kind of the summary statement for address types. In general, this is Mike talking, and maybe Nalini too, I'll let her chime in. Keep it as simple as possible, and keep it to the lowest number of addresses, especially as you're getting started. Keep things simple, keep them working. And so what that will usually mean is a link local address, you have to have that. And then my feeling is you can do everything else with your GUA. And I personally probably would not initially introduce EULAs or any of the other address types such as privacy until you need them. So that's, I think, all I have to say on address space. So now let's go into the prefix assignments. That's going to mean that we talked about we're going to subdivide into all these /36s. But what does that mean? How are we going to provide values to that? How are we going to provide meaning to that? So I'm in terms of an analogy. So we went to the RIR and said, hey, I want a /28. And they said, okay, here, you're going to get that. So that's your /28. That's what you're going to use all the time. So we, the internal staff, the IPAM staff, the IP address management staff, now we need to do that at a lower level for the /36s. We need to assign some meaning or some values to the A bits. Again, back to that messy slide that we had a couple slides ago. And the intent is to use these 36s for internal use. You might have multiple internal networks, and for your subsidiary divisions or anything else that you decided to define as an addressable entity in your IPv6 space. And I probably should have put rule, whichever it is. We also want to have, room for any partner organizations and future use. So what the heck does that mean? I think at our next page, I think we have an example. So let's go right to that and see if, can you go one? Yeah. Okay. So this is what I was hoping we had. So this is an example of how we could do that. So we know we have 256 of these guys. So let's break them into categories. Let's say we have a bunch of different internal networks. Everybody's got a production network, maybe a few non-production networks. You might have a lab. You might have some things in cloud. So that would be one category. And we said, let's say that's going to be bits 0 through 31. And again, this is just sort of Mike's example ideas. And you got to break it down for what makes sense in your organization, which obviously we don't know right now, but that's why we meet with everybody and try to figure out what the heck we're doing and where we're going. So just a couple other categories. We might have some reserved for multi-homing, and then we want to get into the corporate external areas. In other words, maybe these are organizations that we own or control, which are going to be slightly different than the next category, which is business partners, where we might have a partner network. We might have an industry association we're really tight with, or a government agency we work really closely with. And then as rule, whatever I forgot, says we want to reserve a whole bunch of extra space for growth. Now, while we're on this page, I just want to focus on a couple things. And I'm going to focus on, and if I did this slide again, I'd probably highlight it rather than point, because you can't see me point anyway. I'm going to highlight on the production network 000 and the lab network, and then partner number 1, which is number 64 down there. Reason I'm just pointing those out is we have a couple examples coming up of putting this. So this is just the chart. This is what we came up with. And now how do we put that into use? So in a couple of slides, we have some examples and I'm going to use those 3 as examples. And I think that's all on this page, Nalini. Okay, so now we're going to talk about routing, and we're going to use our prefixes for routing. And so why would we do that? So we because of our technical and business requirements, we think that carving all this stuff up into /36s best supports our organization's business model and technical requirements. So it probably makes sense that we would use that as our default routing prefix and aggregate routes to that level. And Nalini covered aggregation last week, and I think she yelled at us a lot how important it was, and it really is. And I'm going to try to hammer that home just a little bit right now. But before we go on to the next slide, and this isn't Mike talking, this is just IETF or and anyone that's setting standards for IPv6. We've selected a /36, but not a good idea to go anything longer than a 64, because IPv6 assumes that you're not going to be doing anything longer, and certain functions may not work, such as Slack, which is really important. We'll talk about Slack, and I think Nalini's already covered that in previous presentations as well. So just note that. So if you don't want to use 36 and you use something else, don't use like a /72 or something like that as your default routing prefix. So I think that's all on that page. Let's just talk a little bit about why this is important, and I'm not going to dwell on this a lot because Nalini covered this last week, and it is rule number 5. This is just a darn good idea. And now, we may have a bunch of baggage out there with v4. In other words, we haven't done as good a job in aggregation there, but now we got this new stuff. It's a chance to put some thought into it and do it right. That's Mike's opinion. It's very important. So let's spend some time to do it and do it right, and we will reap many a benefit as a result. And I'll say this, normally when you look at something like IP routing and aggregation, you're thinking mainly of geographic considerations. but you might want to consider your network traffic patterns as well, because a lot of us have hub sites and things like that, and that may affect to some degree what you want to do. And the final bullet is kind of like a warning that if you just put some addresses into a lot of your platforms, they're going to default to a 64, and that may not give you the ultimate in aggregation or any at all for the most part. So in my opinion, it's worth the extra effort to customize and implement this aggregation, or you will experience aggravation. So I think that's all, and I think we have some examples. Okay, so this is kind of summarize it, and then we'll have, I hope we have some examples of why it's important. Just to summarize, it is very important, and it's important enough to be a separate effort from this address planning initiative that we're talking about today, and do it as a completely separate effort and get all the right people involved. But for now, let's just say it's really important. It can affect performance, availability, and your ability to manage your network. And I'm going to say it's even more important in IPv6 because of the larger numbers. And so here's some examples. And these are the examples that I threatened a few slides ago, that let's say that for our /36s, for production lab and our partner network one that we saw on that, where we assigned the values of the /36s. These are 3 potential aggregated routes aggregated to the /36 level. That means that anything in the production network that you have, or that any partner network, or even the internet that has destination addresses in that space anywhere, can just send to that one address. They only need one entry in their routing table. That's good, that's clean, and that will help you perform better and contribute to availability and management, etc. So that's good. Same thing for the lab and the partner network one. So that's good, that's clean. So where are the without aggravation examples? I'm not going to show you any because they're too terrible, right? No. Next slide, we're going to show a couple of them. And so this slide is still address prefix routing definitions. We're still on that topic, but this is how not to route within your IPv6 address space. So here's an example. Let's say in the first example, we're going to be routing to that particular address, and it's that whole range of addresses. So everything in that /36, and so that's 4K 48s each. So we have 4,000 entries in the routing table. That's horrible, right? Well, no, it could get even worse. You're actually saying your default is /64, so you could have addresses that go all the way to that boundary. So that means it'll include all of your subnets as well, or could. So now look at that range of addresses that you have there. And basically what you're looking there is the 00000 to the FFFFF. And so, but if you add all that up, you could have 270 million entries in your routing table. And that's worth 3 frowny faces, because that would be just horrible for you and everybody. So that's why I say in red highlighted or cap text, it's likely well worth the extra effort to look at this and optimize your routing. Just imagine your poor routers. Nalini, should I pause at that, or should we go on to subnets?
No, I think, okay, so one thing I'm going to say here, as I say, I mean, if you think subnet makes your eyes cross, route aggregation really makes your eyes cross. And I'm telling you, I did not understand until I screwed up. I mean, as is normal, right? Until I did it, I'm like, what have I done with this routing table? Oh my God. And so what I'm, we're having a conversation offline that I'll share with you, is I'd like to get one of the internet registries, to host a sandbox for us, where we set up like some really horrible illustrations of what you can do, what kind of nightmare scenarios you can do. And so then you guys can just log into that, because we will have set it up with a really horrible routing table, and then you can go see it. You know what I mean? And so, as I say, just hold on. And if you don't understand route aggregation and what he's saying, I mean, just take away the idea. You can make a big mess for yourself. You don't want 270 million routes. And but don't worry if you don't understand, and because we'll help you. But yeah, this is great, Mike. Please go on.
Yeah, that's well said. Yeah, just know that it's important and that you should put some time into it, and we'll figure it all out at a later point in time. This is all, like I said, tough, intense stuff. We only have 2 more topics. If you think about our big address map, all those bits and stuff, we've gone through everything except the subnet and the host, and those are pretty consistent with what we understand from IPv4 and anything that we learned previously. So this should go pretty well. There's a few more bits and it's hex, but the subnet is kind of the same. And I want to say this, that in our address space that we looked at on that slide with all the bits, and in sort of default IPv6 addresses and most all documentation you see, you'll see those last several bits before the host address, the last 16 bits are designated as S bits or for subnets. You don't have to do that. You might hate subnets and don't want to use them. You don't have to. I'm suggesting that you do, and here's why I think it makes sense to a lot of organizations who use it today. So why do we use subnets today or tomorrow? Because it can give us some information that we can then provide to users, apps, and tools, and we can manage our networks better. We can also enhance routing efficiency, as we kind of saw on the last page, and we can understand our geographical characteristics just by looking at an address, and that's pretty cool when you're doing triage on a problem. And for some of the things that a lot of us are working on today, microsegmentation and other enhanced security controls, the subnets can be a big advantage in implementing that without a whole lot of pain. I think next, Nalini. And so we usually use, in IPv4, we usually use the subnet to designate a location. I mean, there's other things that people can use it for, but that's the thing that I see the most, and that really helps the help desk, anyone doing triage or diagnostics. It's kind of self-documenting. You can look at an address and something about it right away before you even dig into the problem. And so I'm going to say that subnetting provides great value to both IPv4, and I'm going to say even more to IPv6 once again, because there's so much more of it, and you need that information. It's much harder to look at an address and get some information immediately. And I'm going to say again, and I think we said this before, this applies primarily to your internal network. Again, if we come up with a great subnet standard and then your address goes out on the internet, people aren't expected to know what that means, but you know what it means, your help desk knows what it means, and it provides great value because of that. And next slide, Nalini. So as I said, most of us have some form of this already, and usually it's something we refined over years, and it actually does provide good value, and it has some geographical information, and we might be using that for related controls, and you might build, I've seen things where you build the VLAN in there, some security things, other information. You can use it however you want to best optimize this for your organization's needs. So you can even use it to enhance traffic flow. So I'm going to show an example now of how I think a lot of people use it, which, go on to the next slide, if you would, please. So here's an example. Most of us use private addresses internally, so that's why the 10 dot is there. And so now the sort of the standard, the template there is going to be 10 dot and then rrr.ccc.hhh, and the RRR is the region or the country, or it could be a building, or whatever makes sense to you, and then the CCC is the more refined octet of that, and so that might identify a city or a building, and then the HHH is just the host bits. That's normal. So let's say an example would be the 10 dot 65, and 65, let's say, designates the United States in our big map that we've come up with for our subnets, and then 141 is Chicago. And the bullet in the middle there on the left side, use the middle octet. It's use the 2 middle octets. Just, mark that down, because otherwise when you look at this later and you get all confused, which one is it? It's both. It's 65 and 141. Those 2 middle octets are what we're using here to identify the location. So that's an example. Now, I think we can go on to the next slide, because so that's the result of years of experience and traffic patterns and geography. So what I'm going to say is, let's cheat and let's not reinvent it for IPv6. Let's borrow that if we can. Is there any way we can plug that into the IPv6 address space? And I think there is. So let's take our same example, the 65.141, that means the Chicago in the US. And all we do is plug that into those 2 octets into the 16 bits of the subnet field in our address and convert it to hex, because that's the way IPv6 is going to use it anyway. IPv6 is hex. So it's 41 is 65 and 8dog is 141. We've mapped it in there. I don't have to do any new procedures, create any new documentation, identify any buildings. They're all done for me. So my point here is, don't reinvent the wheel if you don't have to. Take some shortcuts, cheat if you have to. So, and I think that might be all on subnets. It is. So we're down to the final category, which is host addresses. And those are those final 64 bits on the right side of the IPv6 address, the H bits. So previous presentations have gone into different ways that we can do this. I'm just going to list them there. That we have Slack, various forms of DHCP. We can do manual static, computer generated, and you can have combinations of the above. And I think we've seen that even in previous labs. So just know that there are several methods for assigning these, and you want to pick what makes sense for you. So how do we pick that? And I think if we go on to the next slide, we can talk about that. So each method is going to have various ways to assign the specific bits. Some of them use some form of UI64, which takes the MAC address, and computes the, the host bits. And we kind of talked about this a little bit earlier when we talked about privacy and security addresses. There's industry research going on that suggests that, if you just use the MAC address, maybe a hacker can glean some information about your network. Some people think that, some people don't. Know that privacy addresses are out there if you're concerned with that, and for maybe certain devices. So we're not going to cover that today, but that is an important concept to be aware of. So moving on to another type of address method for generating, Slack is a big one. That's new to IPv6, and it's actually kind of cool given the right situation, especially, I'm going to say, where access to the device might be difficult or the numbers are large. And so Slack is kind of a way to just automatically put something out there. It comes on the network, it gets an address, and away it goes. What could be better than that? I don't think it's right for all situations. So let's go on to the next slide and talk about maybe one that a couple of times where, or a couple of situations where Slack may not make sense. And we might want to do things like static and DHCPv6. I think that a lot of us in large organizations, we love our management and control and configuration. And I think DHCPv6 is going to be big. And we're going to use that for the preponderance of our addresses. I don't know that yet, but I think we do like that control. And so I think that will be big. Again, Slack for situations where things are new or we don't have the real control or want it of a certain type of device like an IoT. So I think DHCPv6 will be big. And manual static, I think, will still be big for our long-standing servers. I think we like those to have static addresses, and we like to control what they are. But know that you can use whatever makes sense to you for your needs, for your use cases, and for your organization. So, and you can have multiples. So I think that's all for those. I think this kind of wraps it up, is that, you know, the host addressing is a large topic, and we'll probably have to have more on that because it is a crucial topic, and maybe even a lab for how we do these types of things. So for now, let's just be aware that there's a lot of good alternatives, and you can pick and choose what's best for you. And it'll probably depend on the role of that particular device and its location in the network. Let's reference Rule 7 again. As you do this, and as you pick these methods and implement them, plan for expansion or growth, good old rule number 7. And another one, because of these huge numbers that IPv6 is bringing to us, it's a great idea to assure that any method interfaces with DNS and IPAM in an effective fashion. And I think that's all for me. What's next? Yeah, I think that's it. Nalini, I'm going to turn it back over to you to talk about classes. And then we almost made it on time. And then I'll stick around for questions if Nalini will. Nalini, we can't hear you if you're saying anything. Or I can't.
Yeah, sorry. Yeah, no, sorry. I got my fingers mixed up in trying to unmute myself. So great, thank you so much, Mike. Let's take a few questions, and yeah, because we're getting some great questions. And for everybody, you know, we will be both posting the foils as we always do, and you can get them on the website. You know, the INTC website, IIESoc website. They're all available to you. And as I say, this is not easy stuff. It's just not easy. So let's go ahead and take some questions about all this. Okay, so let me see. Okay, so first, this is an interesting question, and I guess it's a question. It's an I depend or it depends kind of a question. Okay, so okay, the person is asking. One thing is about price. So sure, I mean, you may want a larger address space, but depending on where you are and who you are, I mean, the cost might be considerably different between a 48 and a 32, or larger. Yeah, Mike, do you want to speak to that a little bit?
Yeah, and I went into it with that attitude as well. Like, I want to get the biggest one that I possibly can. Why wouldn't I? And in those cases, it was free. But what you'll find is that, you know, you'll be very limited if you go with an ISP. But if you go to the RIR, they have a lot of really good, smart people, and they're gonna. If you haven't figured out how you're going to use this, and if you really do need a /28 or a /24 or whatever, they'll figure it out for you. And so you need to do your homework. And I say aim high and plan for expansion, but be somewhat reasonable in your planning, because if you're not, someone will force you to be.
Sure, and then people, it leads to the next question. I mean, cost, it's always a question of like, what do you know, who your organization is and how much money you think it is. We should actually do something like that, is like, what are people charging right now? Because I know we've had this discussion in India about what's NICSI charging these days.
That's a great idea, because it would be so, yeah, I think that's a great idea, because it would be so easy to do. We just, you know, give a couple examples. What's a /28? What's a /32? You know, and it's not much, but what does that mean? And not much is different to you or me, or, you know, depending on how affluent we are at any point in time. So I think that's a great idea.
No, exactly. Not much depends, right? I mean, are you IBM or you know, are you me?
Yeah, just as an example, Nalini can afford a /28, but Mike can't.
Anyways, but yeah, possibly, but probably not. Yeah. Anyway,
he may have a different view on that.
Yeah. So the other question that was on it, and one which we've talked about a little bit, is that for a lot of folks, is like, you know, I mean, for a lot of the internet registries and the national registries, like you know, the one at CNIC in China and NICSI in India. I definitely err. If you just get in the /48, then probably very low justification. What Mike is really talking about is if you are asking for smaller allocations. And again, Mike, you want to talk about a little bit of your thinking? I know we've had this discussion about, like, why would you want kind of as big a space as you can get?
Yeah, and that's kind of what we try to do throughout the course of this presentation. And it's not an easy point to grasp onto until you try this. And there's been organizations that, well, you know, like a /48. And I remember when I was first exposed to it, a /48, like that's way more addresses than exist in the universe or that I would ever use. That's got to be plenty. But if you're going to make effective use of the address space and put meaningful information in there and break it into, you know, buildings or partners or whatever makes sense to you, that's when you start to use those bits up, and that's when you want it bigger. So that's why I say do this first. I get to say it one more time. Do this first before you go apply for an address, because otherwise what's going to happen is you're going to get whatever you're going to get, like let's say a /48, because you can get that for sure without a doubt. They probably wouldn't even give you anything smaller than that these days. So unless you're going to the ISP, they may. And then you're going to start to use it in your network, and you're going to need, you know, subnetting or whatever else you think you need that we've covered today or didn't cover today in your network, and that's going to need some bits to do it right. And then all of a sudden you're going to think, oh, /48 wasn't enough. I need to go back and get a /40 or a /32 or something. And you kind of have to do things all over again, and you don't want to do that. So put the thought into it up front. Try to determine your need. I know it's not easy and it's not rocket science. You know, it won't be definitive to a large degree, but do it, and it'll make your life easier on all the follow-on activities.
Great, thanks, Mike. Yeah, you can still hear me, right? Everything?
Yep.
Okay, so this is an interesting question, and it comes up multiple times. Is like, okay, so if you get an address from, say, one of the internet registries, you know, provider independent, as you were saying, so then will your ISP route it? And so can you talk a little bit as to, you know, that whole concern and you know, and what's going on there?
And I will say, yes, they are supposed to. I am not familiar with any situations where that has not occurred, but if you get it from the ISP and try to use it on another ISP, yes, you may have issues there. But that's a great question. But and maybe someone else in the audience, and Nalini, we can ask some of our experts at IETF or anybody else. I'm just not familiar with anybody getting a PI address and any ISP not being able to or refusing to route it.
Right, but it's an interesting question, and it comes up a lot. And in fact, you know, there's one organization that we're working with on deployment, and they're going to go talk to their ISP right now and have that conversation with them, which leads me to something else. One of the things that we're also, you know, we got so many things that we need to do to support you guys, is we want to start like a frequently asked questions, or like, you know, like a Dear Abby kind of a thing. Because I know some people think, well, do I need to set up as a BGP AS? You know, do I need to set up an autonomous system so I can route that? As my understanding is no, your ISP is the one who's the BGP. You know, they will route it. I mean, you can set up as an AS, but you don't have to. Is that kind of your understanding too, Mike?
Well, it depends on how you're planning to implement it. If you're going to have multiple ISPs, then yes, you need to get an AS. You can't do BGP on the internet without it. So if that's in your plans, and I think that would be a good plan actually, multiple ISPs, then you do need to get an AS. If you just have one ISP and you're more of a simple non-multi-homing IPv6, then you do not need an AS just for IPv6. You need it for multi-homing. And I was going to say one other thing, kind of on the previous question though, and on whether when you get your PI address, can you use it on any ISP? A smart thing would probably be to, if you already know who your ISP is or will be, or ISPs, as you're in that process, ask them, hey, I'm getting this, I'm going to get my, a PI address for IPv6 from my RIR. You guys will route it, right? I just make sure. They're supposed to, but it certainly doesn't hurt to make sure.
No, great idea. And as I say, we're into that exact process, with an installation right now. Okay, now this question comes up a ton. Okay, right, and it's outside the scope of this particular conversation, but let's talk about it, because this is probably the number one question that I get, and it is, what if my ISP doesn't offer IPv6?
Yeah, you don't want my answer to that, but so I'll let you answer. You know what mine's going to be: get a new ISP. But more seriously, you can bring pressure onto them. You can leverage other organizations. If they just refuse to do it for some reason, then going to another ISP might be the right answer. But there are situations out there where there are ISPs that I wouldn't say they just don't or refuse to support it, but maybe they're not doing everything they need to do to support you in the way you need to be supported. So I say engage, Nalini and INTC, or maybe IETF. There are industry organizations that maybe could help with that, and maybe the ISP needs help.
No, that's definitely true. Now, as I said, this is carrying. There's definitely. I mean, look to see more on us in this area, because right now, as I say, we can't do everything. We're just a small crew. Right now, we're focusing on the North America with Aaron, and the Caribbean, Aaron region, and also the APNIC region, and we have very, very good relationships with both of those. And so talk to us, send, you have Drew's email, my email, and Mike's email coming up, coming up on there. Just send us a note. And then, because what we can do, let's just limit it right now to Aaron and APNIC, because we'd love to help the entire world, but not right now. And so, because what we can do is because it's not so easy. You can't just be setting yourself up as an ISP. Some countries will not let you do that. Plus, it's seriously, that's what we want to do. You've got ISP. And if they probably just need a little bit of training or hand-holding, or they need to know there is demand. Because what they may think, well, nobody wants it. And so we can reach out, and probably via the registry, out to that ISP, or figure out some way. But like Mike said, do reach out. It comes to a different question. Okay, so people are asking about, can I just set up my own tunnel? You know what? Easier said than done. Okay. And so I'm going to pass on that question, because what we'll do is we'll put that in one of our people, we've tried that, and it depends, right? Sometimes it's really easy, other times not so fast, and so we will do a frequently asked questions, because as I say, it seems like a really easy answer, rolls right off your tongue, set up a tunnel. Yeah, not so fast sometimes. Okay, we'll just skip, as always. So we're going to end with one final question in the interest of, keeping everybody sane here. And you talked about this a little bit in the beginning. Is it possible to project how many IPv6 addresses from existing IPv4 addresses that we have? So what is your opinion on all of that?
Well, I certainly think that you want to use that as part of your information that you put into sort of our blender that we created today. So, and that's a good indicator, but it would be more or less a starting point, because you're going to have, you want to project forward and see you're going to have a lot more devices. You're going to have a lot more types of devices. You may have needs for having multiple addresses per device. So I say use that as sort of a launching pad or a starting point. and leverage IPv4 however you can. And one thing I don't know if I said it during the course of this, a lot of what I'm saying is inferring that we're going to be, most all of us, dual stack for some time to come. And Nalini, you covered that last week, I'm really sure. So, keep in mind that the IPv4 is probably not going away right away, and probably not for years. I mean, we didn't say this, but I think ultimately, if you look really, really, really long term, you want to go for dual stack, and then really, really, really long term IPv6 only. But I think we're a long, long way away from that. Some organizations have done it, so it's definitely possible. I just think for most of us big guys, it's going to be a while. So yeah, use your IPv4 base information as sort of a starting point would be my thought.
Yes, great. Oh, thank you so much, Mike. And then do come to our upcoming webinars. I've got our contact information in there, and we will be sending you all a link to the recording and everything else. So thank you again, and then we hope to see you next time. Okay.
Thank you, everybody.
Yeah. Alrighty. Okay. Let me go ahead and stop recording.